In this section, we'll discuss the various methods that are used to clean textiles. We'll split up cleaning methods into two categories, methods that use liquid and methods that don't. In the wet cleaning category, we'll talk about traditional laundering as well as dry cleaning, the kind of cleaning that your dry cleaner does, which actually does use liquid, but not water. In the liquid-less cleaning category, we'll talk about using ozone, autoclave, which is heat and pressure, ultraviolet radiation, and a few approaches to self-cleaning textiles. Let's start with laundering. Traditional laundering involves a detergent dissolved in a solvent, which is usually water. Detergents are mainly made of a surfactant ingredient, which we'll talk about in just a second, plus some additives. These are things like scents and perfumes and optical brighteners. Brighteners are fluorescent compounds that absorb light in the visible spectrum and then emit it in the ultraviolet spectrum, which is on the blue or purple end of the visual spectrum. This is meant to counteract a yellowing effect in white textiles, which happens when the blue or purple end of the visual spectrum is missing in the light reflected from the white material. Sometimes detergents also include bleach, which works by disrupting the chemical bonds in the chromophore, which is the part of a molecule that controls the absorption and reflection of light in organic compounds. UV light does the same thing over time. The high-energy photons in UV light disrupt the same chromophore bonds. Bleaching also denatures microbes, so it has an antimicrobial effect as well. Finally, detergents often include an anti-redeposition agent and/or a dye transfer inhibitor, which bind to dirt and color to prevent them from being redeposited on fabrics during washing. The surfactant is the main ingredient in any detergent. Surfactants are everywhere in our world, in all soaps, toothpastes, and many other things that we use every day. A surfactant is a compound that has a hydrophilic head and a hydrophobic tail. The hydrophobic tail is oil-soluble, meaning that it can stick to oil molecules, but the hydrophilic head is water-soluble, so it can stick to water. So when oil is mixed with water, it sticks to itself and to the fabrics that it might be attached to, much better than it sticks to water, so water doesn't really help get it off. If you've ever had greasy hands and tried to wash them with water, you know how hard it is to get that oil off. But if you add a surfactant, the oil bonds to the surfactant's tail more easily than anything else. So each surfactant compound gets its tail stuck to the oil with its head sticking out, and as they get packed in, they make a little ball of surfactant-coated oil. Soon all of the oil is broken up into surfactant-coated balls. Because the heads are hydrophilic, they can be carried away easily with water. What we know as dry cleaning works in a very similar way. Dry cleaning doesn't use water, which can damage some fibers like silk. Instead, it uses a different solvent. There are a variety of options, but right now the most common are synthetic petroleum, which is an improved version of the original dry cleaning solvent, which is petroleum, and perchloroethylene, known as PERC. Liquid CO2 is a less commonly used solvent that's newer to the dry cleaning industry. Detergents used in dry cleaning are similar to what's used in traditional laundering. Their main ingredient is also a surfactant. Because the solvent used in dry cleaning is usually reused over and over, it's often run through a charcoal filter to remove contaminants so that they aren't redeposited onto other clothes. One of the challenges of wet cleaning is that it usually involves a pretty rough mechanical environment. The textiles are agitated to loosen dirt and stains and to help the solvent penetrate the textile structure. Non-liquid cleaning most commonly doesn't rely on agitation. It uses gases or radiant energy to permeate the textile. There are a variety of methods used to clean textiles without liquids. Some are replacements for laundering, meant to be done periodically, and some are continuous clean technologies that remove the need to clean the item periodically. Let's start with ozone. Ozone is a particularly reactive gas, which means that it encourages other molecules to oxidize and react with it. When molecules and contaminants and odors react with ozone, they break down into other substances. Ozone is heavier than air, so in Earth gravity it can be injected into the top of a container and it will fall down to the bottom, although some ozone cleaning systems also use a tumble drum to move textiles around within the gas. An added benefit of ozone is that it smells fresh. It's the smell that we associate with clean air. Ultraviolet radiation has much the same effect as bleach on chromophores. It breaks down bonds and over time will cause stains and dyes to lose color. You may have seen this on drapes or on the back of a couch facing a window. The UV in sunlight will discolor the fabrics. It takes a lot longer than bleach, and it only works on exposed surfaces, so anything that's not exposed to light won't be broken down, as opposed to bleach that will seep into all the crevices of a textile. UV also breaks down bacteria though, so it can also remove and prevent body odors. Autoclaves use heat and steam and vacuum to sterilize surfaces by killing bacteria. This method works for textiles, but it won't remove stains or soil. It will only prevent odor-producing bacteria from growing. Finally, self-cleaning surfaces try to remove the need for cleaning by continuously removing contaminants and preventing stains. In the hygiene section, we talked about some methods of doing that, including superphobic surfaces and antimicrobial materials and finishes. Surfaces like fluorocarbon finishes cause liquids to bead up and roll off, and in the process, they can pick up dirt and particles. Micro and nanoparticles can be used to create these complicated surface textures we discussed in the hygiene section that help repel water and oil. The last category of approaches to self-cleaning that we haven't talked about are photocatalytic materials. Surfaces or coatings that are activated by light and use light energy to break down contaminants, bacteria, and colorants. One of the most common of these materials is titanium dioxide. When exposed to light, the electrons in titanium dioxide gain energy and react with oxygen in the air, acting as oxidizing agents to break down organic compounds. Because titanium dioxide is the catalyst, not actually part of the reaction, it doesn't get used up, so it won't wear out. Silver and copper nanostructures have also been explored for this purpose, absorbing visible light and using it to catalyze a reaction with other molecules.